My name's Reina, and I'm here to talk to you about device administrator use and abuse in Android, detecting and characterizing it. So let's start off by talking about Android's device administrator. In the Settings app, you can find a list of applications that have device administrator. And they're usually implemented to allow tighter or remote control on Android devices. And usually they're used by enterprises or parents. So let's click on this app over here. And you can see that the user themselves have to enable the app to have access to these privileges. In addition, the user has to be able to deactivate these privileges if they want to uninstall the application. So here we can see the app has been activated. Now, what happens when you can't deactivate these privileges? Well, in this app's case, you get locked out of your phone. In another app's case, the Settings app crashes when you try to disable these privileges. In other words, the app cannot be uninstalled, but only through a very extreme way, such as factory resetting your phone. This type of behavior is what we characterize as DDA, or Deathless Device Administrator. So our approach detects this behavior. We use DAAX on an app, and we retrieve a DDA report. So DAAX is known for DA Abuse Exposer. It's a tool we developed, which uses static analysis to expose potential DA abuse. Some applications include that we were able to confirm DDA in roughly 500 apps, including some that are on Google Play. We defined some DDA-induced families in malware, and we established DDA attack resistance across different Android versions. DAAX is effective and efficient. We have an 84.8% F measure, and it takes roughly 205 seconds to analyze an app. So where do these DA apps come from? Well, many of them are pre-installed on your device by Google, your device vendor, or other sources. And you can also download them yourselves in different categories, as you can see here. And they're in different types of applications, such as security apps, enterprise apps, parental control apps, lock screen, themed launchers, etc. There are many types. There are lots of different behaviors that DA induces, such as lock screen, erasing all your data, changing the screen lock password, setting storage encryption, monitoring screen unlock attempts, setting lock screen password expiration, disabling features in KeyGuard, setting password rules, and disabling cameras. One thing to note about these 4 behaviors is that as of Android 9, they have been deprecated, but it is also important to note that currently 89% of devices are running a version that is lower than Android 9. So we can say that these behaviors still persist. Overall, all of these behaviors can be abused to create deathless device administrator apps, or in other words, apps which prevent the user from uninstalling itself. We categorized 3 types of DDA. We have DDA reset, where the device has to be factory reset in order to remove the app. We have DDA hide, where apps are hidden from the DA list in the Settings app. And we have DDA expert, where DA can be disabled, but it's not obvious, and it's quite difficult for the average user to accomplish this. So let's talk about DAAX's architecture. So we first have an APK, and by using Soot and FlowDroid, we retrieve the call graph of the APK. There, we apply DA receiver analysis, where we check the XML code and byte code to see whether DA broadcast receiver is claimed and implemented, or in other words, if DA has been activated by the app. Next, we do DA activation analysis, followed by pre-deactivation analysis. Here, we check whether the app is attempting to block or dismiss dialogues from the user. Finally, we do a post-deactivation analysis. This is really important because many DDA apps, after the user attempts to deactivate the app, it tries to lure the user into reactivating the device administrator privilege. Overall, these analyses enable us to identify whether an app is DDA hide, DDA expert, and DDA reset. For DDA reset, we had to perform an additional analysis. We had to do a timing analysis because many DDA reset apps forces the device to lock and sleep, which prevents the user from viewing any kind of warning dialogues. So we looked at roughly 39,000 apps to check if they have DA. We did this automatically using DAAX and some scripts to install it on devices, and we used a UI automator to check whether or not it appears on the settings DA list. That leaves us with 4,000 apps that have DA. We then manually attempted to deactivate the DA, restart settings, and check whether or not DA is still deactivated. This reveals DDA reset and DDA expert apps. We also manually checked whether an app had the DA permission but was not appearing in the settings list, thus revealing DDA hide apps. And here we have a split. We have roughly 3,000 apps that are not DDA, but we have 785 potential DDA apps. Apps are categorized as not DDA because they appear in settings and they can be uninstalled. And we characterize DDA apps because we actually observed that behavior, or it was reported as DDA by our tool DAAX. Overall, the most popular DDA types were DDA reset and DDA expert. And of course, there are a few limitations with our approach. We do have false positives and negatives due to the fact that static analysis precision versus scalability has a trade-off, and also there is over-approximation with static analysis. Nevertheless, our F measure is quite good because it is above 80% overall, which lets us conclude that DAAX is effective. And again, since the analysis time was only 205 seconds per app, we can say that DAAX is efficient. What's also interesting is seeing how DDA behavior changes across Android versions. So we looked at 5 different Android versions, and we looked at a subset of 301 malicious apps and 42 benign apps. And we discovered that in malicious apps, DDA reset reduces as the version of Android increases, and DDA expert increases along with newer versions. This is because in Android 8, the user is able to bypass intrusive overlays, and in Android 7.1, for a device administrator app, the user can actually uninstall it within the settings app itself after you deactivate it too. And because of this, we see a similar trend in benign apps where DDA expert reduces in new versions. So one thing to know, though, is that despite these improvements, newer versions of Android do not eliminate DDA behaviors, which is still quite concerning. As a result, we filed a disclosure with Google, which was acknowledged as a moderate severity due to several security implications, such as local permanent denial of service and local bypass of user interaction requirements. And as a result, 1 app was actually removed from Google Play. 5 apps had those DDA issues fixed, and we're still waiting on a few more apps to see what will happen with them. And to conclude, our research characterized and quantified legitimate as well as nefarious use of device administrator capabilities in Android. We developed DAAX, which is a tool that has revealed certain issues in more than 500 apps, including those that are on Google Play. We defined DDA-induced families in malicious apps, which, if you are interested, I would recommend to see our paper about it. And finally, we have established DDA attack resistance across Android versions. So thank you, and I'm ready to take any questions.